Well, good morning. My name is Olivia Johnson, and I'm a PhD candidate at the University of Tasmania's Institute for Marine and Antarctic Studies. Before I start my talk, I would like to acknowledge that I'm extremely fortunate to work on Lutruwita, Tasmania, Aboriginal land, sea and waterways. I'd also like to acknowledge with deep respect the traditional owners of this land, the Muwinina people, which I'm giving this presentation from today. I'd like to give thanks to the Australian Wildlife Society, firstly for providing me with funding towards presenting my research at the upcoming Indo-Pacific Fish Conference in New Zealand, and for inviting me to present and participate in the webinar today. So some brief background on marine biodiversity. Reef ecosystems, both coral reefs and rocky reefs, are some of the most productive and diverse systems on the planet. Australia has extremely rich marine biodiversity, making it completely unique. The endemism is some of the highest globally. For example, 50% of algae species and some of the others listed on the screen are not found anywhere else on Earth. So this results in distinct coastlines around Australia that hold unique biogeographic regions for both rocky and coral reef ecosystems. The oceans are integral to our way of life. They support a range of ecosystem services that have ecological, social and economic implications. But with 87% of our oceans having been modified by humans, they're currently facing a biodiversity crisis. These threats and changes are multifaceted, and they include things such as climate change, ocean acidification, and marine heat waves, just to name a few. When it comes to marine species declines, population trend and distribution data is logistically challenging to collect for marine species. Beyond commercially important or highly charismatic species, few marine species are studied in any great detail. Many species are also rare by nature and are often highly cryptic. So this makes it really difficult to collect data on marine species. Just a couple of facts: incredibly, invertebrates have 1,000 times fewer conservation papers compared to turtles, and compared to birds, amphibians and mammals, as little as 0.1% of marine invertebrates and fish are considered threatened. Rare and endemic species are most susceptible to extinction due to restricted geographic range or small population size, and rapid species declines or rare species can cause overall implications for resource monitoring of those species. Therefore, this makes the extinction risk in marine taxa much higher than terrestrial species. For my project, density data has been obtained from two long-term reef monitoring initiatives, which include the Australian Temperate Reef Collaboration, which has been running since 1992, and the Reef Life Survey, which is a citizen science initiative that's been running since 2007. Both initiatives apply comparable underwater visual surveys along 50-metre transect lines, with dive searches applying different methods, typically in 5 to 10 metres, to survey fish, mobile invertebrates, algae and coral species. You can find more about the methods on each of their websites. So for my project, the combined program has over 2 million abundance records, but this was reduced to 100,000 records, or nearly 100,000 records across both the programs. And this comprised of 100 macroalgae species, 21 coral species, 541 fish species, 140 invertebrate species, and this was from up to 465 sites around Australia over the 14-year period. So we conducted a series of linear mixed effects models on the species, just described to understand their population trends. And of the 705 species, we found 130 species with significant population trends. 53% of these species were in decline, and of those in decline, 64% were found to be Australian endemic species, which is shown in this plot on the screen. From further investigation, we also found that 25% of endemics experiencing declining populations would qualify in a threatened category currently listed on the IUCN. Those species are currently listed on the IUCN, but as least concern, and the oldest assessment dates back nearly 2 decades to April 2004. And 73% of the endemics with significantly declining population trends have not had a conservation status evaluated. So this is just a little snippet of what will comprise my first chapter of my PhD. which is hoping to highlight the disproportionate number of Australian endemic marine species in decline that lack any type of conservation assessment and could potentially be heading towards extinction, as well as the need for timely reevaluations of listing assessments from government and IUCN Red List authorities to ensure species are adequately protected. I'd just like to thank my supervisors and everyone else who's assisted me with my project so far, RLS and HRC for the use of their long-term monitoring data, the Ecological Society of Australia for funding me for multiple years of additional field surveys, and most importantly, the Australian Wildlife Society for providing me with funding today to present my results and also at an international conference. Thank you very much.